Hello and welcome to the video on built-in machine learning algorithms in AWS SageMaker. Here we are on the AWS docs page, and based on some documentation that they have given us, I'll explain you some important concepts before we move to the practical implementation from the next few videos. So the most important part while working on a machine learning problem is to choose the correct algorithm for the correct kind of machine learning problem that we are trying to solve. So choose an algorithm. Machine learning can help you accomplish empirical tasks that require some sort of inductive inference. This task involves induction as it uses data to train the algorithms to make generalizable inferences. This means that the algorithms can make statistically reliable predictions or decisions or complete other tasks when applied to new data that was unseen for them and they were not trained on that the new data. To help you select the best algorithm for our task, we classify these tasks on various levels of abstraction. At the highest level of abstraction, machine learning attempts to find patterns, relationships between the features, and less structured items. So currently, we have three basic paradigms for machine learning used to address various type of problems. The first one that we have is the supervised machine learning. The basics of the supervised and supervised we have already covered in the machine learning concepts, but still again, just for the sake of completion of the SageMaker section, I am just revisiting this machine learning paradigms. Supervised machine learning, this is probably the first and most used machine learning paradigm. So let's see how we can use this paradigm to solve our different problems that we'll see in the next case studies. If your dataset consists of features or attributes that are the inputs that contain target values outputs, then you have a supervised learning problem. If your target values are categorical, that means mathematically discrete, then you have a classification problem. It is a standard practice to distinguish binary and multi-class classification. So on the top we have supervised machine learning. Under supervised machine learning we have two different classes. The first one is classification and the second one is regression. Again, inside classification we have two different types of problems, that is binary classification and multi-class classification. First let's read the text and then I'll give you some real life examples for your better understanding. Binary classification is a type of supervised learning that assigns an individual to one of two predefined and mutually exclusive classes based on individual's attribute. A good example of binary classification problem can be like based on the student's IQ and CGPA, you are trying to predict whether the student will be placed or not, or he or she will get a job or not. So the target in the target column will have two different outputs like 1 or 0. If we have 1, that means the student is placed, and if 0, the student is not placed. So this is a binary classification. Either the student will get a job or he or she won't get. It is a supervised learning problem because the models are trained using examples in which the attributes are provided with correctly labeled objects. A medical diagnosis for whether an individual has a disease or not based on the result of diagnostic test is an example of binary classification. Let's study about multi-class classification. So it is a type of supervised learning that assigns an individual to one of the several classes based on individual's attributes. It is supervised because the models are trained using examples in which attributes are provided with correctly labeled objects. An example of prediction of the topic most relevant to a text document. A document may be classified as about being religion, politics, finance, or as one of the predefined classes. So let's say you have a text document and there are several classes that you can categorize into that. So either the document can belong to finance section, it can belong to technology section, it can belong to politics or something else. So this is a very good example of a multi-class classification problem that we have. So AWS SageMaker has already some pre-trained built models that we can use to solve this different type of machine learning problems. I'll show how we can do that in the next few videos. If the target values you are trying to predict are mathematically continuous, then you have a regression problem. So this is again the next class under the supervised learning category. So the first two classes were classification and regression, and inside classification you had binary and multi-class. Again we are studying about regression. If you are trying to predict a mathematically continuous value, let me give you a very good example of regression. Let's say based on the CGPA, IQ and number of years of experience of a person, you are trying to predict the value of the salary for that person. So if the person is having a CGPA of 9 and he is having some XYZ value of IQ and he is having a 3 years of experience, then your, let's say the salary is $100,000 or something like that. So you are trying to predict a mathematically continuous value or a number. So that type of problem falls under the regression problem. Regression estimates the values of a dependent variable based on one or more other variables or attributes that are correlated with it. An example is a prediction of house prices using features like number of bathrooms, bedrooms, square foot of the house, and garden. Regression analysis can create a model that takes one or more of these features as an input, and it will predict the price of the house. So built-in supervised machine learning models are already provided by SageMaker, so we can use them. Mostly our case studies will be focused on the supervised learning. So in the next few videos, we'll see the practical implementation of few algorithms. And let us see the built-in SageMaker algorithms that we'll use in the next few videos. So some of the most popular algorithms that we have is CatBoost, KNN, LightGBM, Linear Learner, or XGBoost algorithm. So you can click over here and it will give you a detailed explanation of linear learner algorithm. So linear learner over here, as you can see, it can be used to solve both classification and regression problems. Now when you are solving a classification problem, so your metrics to determine the performance of the model will be more of precision, recall, accuracy, F1 score, something like that. But if you're trying to solve a regression problem, then your metrics to evaluate the performance of your machine learning model will be cross entropy loss, absolute error, mean squared error, or R2 score. So these are different metrics that you have that you use to evaluate the performance of your model. So this is detailed info about your linear learner, one of the very popular ML model on AWS. Similarly, if you want to study about, let's say, this XGBoost, another very powerful machine learning algorithm. So these are some pre-trained models that are already given to us by SageMaker. We just have to directly use them. So I hope you're clear with what we have discussed in this video. In the next few videos, I'll show you the practical implementation of all these